In 1963, Porsche did something that the rest of the automotive world thought was completely insane. They took an air-cooled flat-six engine, a configuration most engineers considered outdated, and dropped it into the back of a sports car. The experts said it would never work. Too hot, too complicated, too different. And for more than 50 years, Porsche proved every single one of them wrong. This is the story of the 911's flat-six engine and how a bunch of stubborn German engineers outsmarted the entire V8 establishment. Along the way, we'll encounter revolutionary cooling systems, racing dominance that nobody saw coming, and a design philosophy that turned conventional wisdom completely on its head. So let's begin. But first, what exactly was wrong with the way everyone else was building engines? Now, to understand why the flat-six was such a gamble, you need to understand what the automotive world looked like in the early 1960s. The V8 was king, especially in America, where bigger meant better, and displacement was the answer to every performance question. You want more power? More cylinders, more cubic inches. Simple. The V8 configuration made sense for a lot of reasons. It was compact for its displacement. It was naturally balanced. And most importantly, it was easy to cool with a conventional front-mounted radiator setup. Water goes in, heat comes out, everyone goes home happy. The thing is, Porsche wasn't trying to build an American muscle car. They were trying to build something else entirely, a sports car that could handle. And handling, as any engineer will tell you, is all about weight distribution. See, when you put a big heavy engine in the front of a car, you get what's called understeer. The front pushes wide in corners because there's too much mass over the front wheels. It's predictable, sure, safe even, but it's not exactly thrilling. Ferdinand Porsche, and later his grandson Ferdinand Alexander, had a different idea. What if you put the engine behind the rear axle, way back there, hanging off the back like a pendulum? Now, I know what you're thinking. That sounds like a terrible idea, and honestly, on paper, it kind of is. You get oversteer. The back end wants to swing around in corners. It's twitchy, unpredictable, the kind of handling characteristic that can bite you if you're not careful. But here's where it gets interesting. The Porsche engineers realized that oversteer, while dangerous in the wrong hands, actually makes a car faster in the right hands. You can rotate the car into corners, use the weight transfer to your advantage. It's harder to master, but once you do, you're faster than everyone who took the easy way out. I mention this because the engine placement dictated everything about the flat-six design. With the engine behind the rear axle, space was at a premium. You couldn't just drop a tall V8 back there. You needed something flat, something compact, something that would keep the center of gravity as low as possible. Enter the boxer configuration. A boxer engine, also called a flat engine or horizontally opposed engine, has its cylinders laid out flat, pointing away from each other on opposite sides of the crankshaft. Picture two boxers throwing punches at each other. That's where the name comes from. When one piston moves out, the opposing piston moves out too. They're punching away from each other, which creates a natural balance that's hard to achieve with other configurations. Now, Porsche didn't invent the boxer engine. That honor goes to Carl Benz, way back in 1896. And Volkswagen had been using flat-four engines in the Beetle for decades, but Porsche took the concept and pushed it further than anyone thought possible. The original 911 flat-six displaced just 2 liters. That's tiny by American standards. A typical Chevy small block of the era was 5.7 liters, almost 3 times the size. But the Porsche made 130 horsepower from those 2 liters, which was remarkably efficient for 1963. And more importantly, it weighed almost nothing compared to a cast-iron V8. The air cooling system was the really clever part. See, most engines use water to carry heat away from the cylinders. You've got a radiator up front, coolant passages running through the engine block, a water pump, hoses, a thermostat. It's a whole system with a lot of parts that can fail. Porsche looked at all that complexity and said, what if we just used air instead? The flat six had large cooling fins machined into the cylinder heads and barrels. A big fan, driven by the engine itself, forced air across those fins and pulled heat away. No radiator, no water pump, no coolant to leak. The engine ran hotter than a water-cooled design, sure, but it was simpler, lighter. And in a rear-engine car where packaging was everything, it freed up space that would otherwise be taken by cooling system components. Here's the thing about air cooling that most people don't appreciate. It's really hard to do well. Air doesn't absorb heat as efficiently as water. The temperature differential between the front and rear cylinders can cause uneven thermal expansion, which leads to all sorts of problems. Oil leaks, head gasket issues, warped cylinder bores. The engineers at Porsche spent decades refining the cooling system to make it work reliably under racing conditions. And racing, as we'll see, was where the flat six really proved itself. By the late 1960s, the 911 had established itself as a serious competitor in European racing. But the real breakthrough came in 1970, when Porsche decided to go all in on endurance racing. They took the basic flat six architecture and did something radical. They added turbochargers. Now, turbocharging wasn't new in 1970, but putting a turbo on an air-cooled engine? That was considered borderline suicidal. Turbos generate enormous heat. The exhaust gases driving the turbine can exceed 1,000 degrees. Adding that kind of thermal load to an engine that was already running hot seemed like a recipe for catastrophic failure. The Porsche engineers solved this with intercoolers, heat exchangers that cooled the compressed air before it entered the engine, and by developing oil cooling systems that could handle the additional stress. The result was the 917, which dominated Le Mans in 1970 and 1971 with a turbocharged flat 12 derived from the flat 6 architecture. But the real magic happened when they brought turbo technology back to the production 911. The 1975 Porsche 930, known simply as the Turbo, was unlike anything else on the road. 300 horsepower from a 3-liter engine at a time when most American V8s were making 200 or less thanks to emissions regulations. The flat 6, with its compact dimensions and efficient breathing, actually benefited from the emissions era that was strangling conventional engines. Think about that for a second. While American manufacturers were detuning their V8s and adding catalytic converters that killed performance, Porsche was using forced induction to make more power than ever. The layout that everyone said wouldn't work was suddenly the most advanced thing on 4 wheels. If you've made it this far, you're probably into this kind of stuff. Quick question, where are you watching from? Drop it in the comments. And hey, subscribe if you haven't. We do this every week. All right, let's talk about what made the flat 6 configuration so fundamentally different from the V8s it was competing against. The Boxer layout has inherent advantages that go beyond just being flat and compact. Because the pistons move horizontally, the engine has a very low center of gravity, lower than a V8, lower than an inline 6. This matters enormously in a sports car, because every millimeter you can lower the center of gravity improves handling. There's also the matter of balance. In a Boxer 6, the pistons are arranged so that their movements naturally cancel out most primary and secondary vibrations. The engine doesn't need heavy balance shafts like some inline configurations do. It's smooth in a way that seems almost mechanical magic. This violent process of internal combustion somehow translating into this refined, harmonious rotation. The sound is different too. A V8 has that familiar burble, that bass-heavy rumble that comes from the firing order and the exhaust setup. The flat 6 has something else entirely, a mechanical whir at idle, then this rising howl as the revs climb. It sounds alive in a way that's hard to describe. People talk about it like it's a musical instrument, which I always thought was overblown until I actually heard one at full throttle. Now I get it. But there were challenges, real ones. The biggest was cooling those rear cylinders. In any air-cooled engine, the cylinders at the front get the freshest, coolest air. By the time that air reaches the rear cylinders, it's already absorbed heat from the front ones. In a flat six, this problem is even more pronounced because all the cylinders are basically in the same horizontal plane. The engineers at Porsche had to design incredibly sophisticated ducting to ensure adequate airflow to every cylinder. They also had to deal with thermal cycling. Every time you start an air-cooled engine and bring it up to operating temperature, then shut it off and let it cool down, the metal expands and contracts. Do this enough times, and you get fatigue. Cracks form. Gaskets fail. The early flat sixes had real reliability issues until Porsche developed better alloys and improved the casting techniques for the cylinder heads. Oil leaks were another constant battle. The flat six has a huge surface area, all those fins, all those external oil passages. Every joint is a potential leak point. Porsche owners became accustomed to checking their oil regularly and accepting that a few drops on the garage floor was just part of the ownership experience. And yet, despite all these challenges, the flat six kept getting better, more powerful, more refined, more reliable. By the 1980s, Porsche was extracting over 300 horsepower from the 3.3-liter turbocharged version. By the early 1990s, the naturally aspirated 3.6-liter engines in the 964 and 993 generations were making close to 300 horsepower without any forced induction at all. The efficiency gains were remarkable. Better cylinder head designs, improved fuel injection, more sophisticated engine management systems. The 993, which ran from 1994 to 1998, represented the peak of air-cooled development. Porsche threw everything they had at it. The engine featured variable valve timing, an adjustable system called Varioram that changed the intake runner length depending on engine speed. At low RPM, the runners were long, which improved torque. At high RPM, they shortened, which improved top-end power. It was the kind of engineering solution that only makes sense when you've spent 3 decades perfecting a basic architecture. And then Porsche did something that broke hearts around the world. They killed air cooling. The 1999 model year 911, known as the 996, arrived with a water-cooled flat six. Enthusiasts were outraged. This was heresy, betrayal, the end of an era. Porsche tried to explain that emissions regulations and noise standards had made air cooling impractical, that water cooling allowed for better temperature control and more power, that the new engine was actually superior in every measurable way. None of that mattered to the purists. They felt like something essential had been lost. But here's the thing, and this is important. The flat six configuration itself survived. The engine was still a boxer six, still mounted behind the rear axle, still made that distinctive Porsche sound, even if it was slightly muted by the cooling jackets. The fundamental DNA of the 911 engine remained intact, and Porsche kept pushing the platform forward. The 997 generation brought direct injection. The 991 brought turbocharging to the base models for the first time since the original turbo. The current 992 generation makes over 400 horsepower in base trim and can exceed 600 horsepower in Turbo S specification. The V8, meanwhile, has been struggling. Emissions regulations are tightening. Electric vehicles are threatening the entire internal combustion paradigm. The big displacement philosophy that dominated American performance for decades is increasingly obsolete. And here's where the flat six architecture looks almost prescient, because it was always about efficiency, about extracting maximum performance from minimum displacement, about engineering cleverness instead of brute force. The things that made the 911 engine seem like a compromise in 1963 have become its greatest strengths in 2024. The turbocharging technology that Porsche pioneered in the 1970s is now standard across the automotive industry. Every manufacturer uses forced induction to make small engines perform like big ones. The flat six was doing that 50 years before everyone else caught on. The low center of gravity that came from the boxer layout? That's exactly what electric vehicles struggle to achieve with their heavy battery packs mounted in the floor. Porsche's platform already had the weight where you want it. Even the rear engine layout, which seemed so counterintuitive, has proven remarkably adaptable. Porsche has been able to create hybrid versions of the 911 by packaging electric motors where the weight helps rather than hurts. The same layout that was a liability in the hands of novice drivers has become a feature that enables all-wheel drive hybrid systems. Let me tell you about the racing record, because this is where the flat six really earned its legend. The 911 has won Le Mans outright, not in class, overall, against purpose-built prototypes with engines twice its size. The 1979 victory with a turbocharged flat six was considered one of the greatest upsets in motorsport history. The Porsche RSR variants have dominated GT racing for decades, winning championships in series all over the world. The engine has powered rally cars through forests and over mountains. It's climbed Pikes Peak faster than anything else with wheels. It set lap records at the Nürburgring that stood for years. The flat six has succeeded in basically every form of motorsport where it's been allowed to compete. And this is what frustrated the V8 establishment for so long. They kept expecting the weird German engine to fail, to overheat, to shake itself apart, to prove that you can't violate the laws of thermodynamics with clever engineering. And it just kept winning. The philosophy behind the flat six influenced an entire school of sports car design. Subaru adopted the boxer configuration for their rally program. Ferrari developed flat 12 engines that dominated Formula One in the 1970s and 1980s. The idea that you could compete with smaller, more efficient engines became the foundation of modern motorsport regulations. There was a period in the 1990s when the 911 was considered outdated. The mid-engined Ferrari 355 was faster around a track. The Honda NSX was more advanced technically. Everyone assumed Porsche would eventually abandon the rear-engined layout and the flat six in favor of something more conventional. They didn't. They kept refining what they had, making it better, solving the problems instead of abandoning the concept. And now, 3 decades later, the 911 is still in production while most of its competitors have been discontinued or completely redesigned. And what of Ferdinand Porsche's original vision? The idea that putting the engine behind the rear axle would create a better handling car? It worked. Not perfectly. The early cars could bite inexperienced drivers, but Porsche developed electronic stability systems, active suspension management, rear-wheel steering, and dozens of other technologies that tamed the handling characteristics while preserving the essential feel. The modern 911 is one of the easiest sports cars to drive quickly, which is ironic given how difficult the early versions were. The flat six engine sits at the heart of all this, still air-cooled in spirit even if water flows through its jackets now. Still compact, still efficient, still making that distinctive sound that enthusiasts recognize from 100 meters away. Ferdinand Alexander Porsche, who designed the original 911 body, passed away in 2012. He lived long enough to see his grandfather's engine concept become one of the most successful in automotive history. More than 1 million 911s have been built, every single one powered by a flat six. The critics who said it wouldn't work? Most of them are retired now, their conventional wisdom proven wrong by 60 years of continuous development. The engine that was too complicated, too different, too risky became the benchmark against which all other sports car engines are measured. There's a lesson in that, I think. Sometimes the unconventional approach, the one that requires more effort and more engineering and more faith, turns out to be right. Sometimes the experts are wrong. Sometimes the weird solution is the best solution. The Porsche Flat Six proved that you didn't need 8 cylinders to make power. You didn't need water cooling to be reliable. You didn't need the engine in the front to handle well. You just needed brilliant engineers who were willing to solve hard problems instead of avoiding them. And that is the story of the Porsche 911 Flat 6 engine. If you enjoyed this one, subscribe for more. Let me know in the comments. Had you ever heard about how the air cooling system actually worked before this? Take care, and I'll see you in the next one.